So this is work I'm going to talk to you about that I've done with a PhD student, Becky Garbett, and also colleagues from Raptors Botswana, which is a conservation NGO in Botswana. So this work was published last year. If anybody wants a copy of this paper, I'm more than happy to give you a copy of that. So this is the reference for that paper. So looking now at the history of research on lead and wild birds, obviously we've just heard about it in crocodilia, and also John gave a really nice overview this morning. But obviously it has been researched intensively in relation to wild birds for over 50 years now. And that research interest continues to increase. So this is the number of citations per year from the 1950s onwards from Web of Science. You can see over the last 10 years there's been a dramatic increase in the research interest and the number of times papers have been cited in relation to lead and wild birds. And from that wealth of research and background information, we know that there's two groups of birds that are most effective. They are water birds and scavenging raptors. And we also know that the cause of that elevated lead levels within those birds is principally through fishing tackle and lead ammunition. We also know that it can have population level effects on bird species. So this paper, this graph here, is showing you that the population trends of different waterfowl species in relation to the amount of lead shot that's ingested. And you can see that those species that ingest more lead have more negative population trends. And perhaps the most well-known example of population level impacts is the impacts of lead on the Californian condor. So the result of lead ammunition led to the very, very near a complete extinction of that species. So because of this wealth of information, Plaza and Lambertici conducted a review of the impacts of lead or of the research that's taken place on lead contamination in wild vultures and condors. It was published again earlier this year in Science and Total Environment. And I just want to highlight some of those key results from that paper. So first of all, they found that lead contamination was a threat in every geographic area in which vultures were present. They also found that most studies found individuals with lead concentrations above that threshold level. And because of that finding, that when people go looking for lead and search and test those birds, they find that at least some individuals have elevated levels. They suggested that lead contamination could be underdiagnosed in many parts of the world. So a little bit like those uninspected findings that John was talking about. If you go searching for it, if you go look at it, you'll often find that that is the case, that there is elevated lead levels in the system, and therefore the levels of poisoning in terms of the distribution are probably undiagnosed and very, very high. The other interesting point from our perspective is that they found that Africa was the least studied region globally, with only 7% of studies coming out of Africa. And they also reported that the most common source of lead ammunition from these studies was, elevated lead levels was lead ammunition. And indeed, in 13% of these cases, it was attributed to lead ammunition definitively through isotope analyses. So how does lead from lead ammunition get into vultures? Well, it's a relatively straightforward process. As the bullet gets shot through the animal, fragments of lead, including microscopic fragments, get dissipated throughout the carcass of the animal. So here you can see an X-ray of a deer that's been shot, and you can see little specks of lead distributed throughout the carcass. And the key thing to me, which really kind of blew my mind when I found out this, is that these fragments can distribute huge distances away from the entry wound. I think up to 14 inches away these things can go. So when the bullet goes through, the amount of meat and viscera that can potentially be contaminated with lead ammunition is quite great. And obviously, when animals are shot and aren't recovered, for example, when you get an injured animal and it dies in the veldt, or else when the offal is taken out, or the growlach, as we say in Scotland, is distributed into the fields, vultures can often come down and feed on these parts. They take it on board, they ingest it, and then through the ingestion of the lead, that's then goes out to the bloodstream, and then is laid down in tissues, other soft tissues, and also ultimately the bones. So Obviously, lead can have lethal effects. It can kill animals outright, birds outright if the levels are high, but it can also have profound sublethal effects. And a paper was published late last year. It was one of the first studies to show a sublethal effect in terms of productivity of the Benelli of a raptor. So this study was on Benelli's eagles, and they found that those individuals with elevated lead levels had lower productivity. So you can actually have you can see how you can have a demographic consequences of sublethal levels of lead contamination. And this is one study that I think is really interesting as well, and potentially has quite profound implications for vulture conservation. This was a study on mute swans that found that those individuals that had some individuals that had elevated levels of lead were more prone to collision with power lines if they had sublethal elevated levels of lead, which I think is potentially really interesting. So why are we interested in vultures in Africa? Well, as you heard yesterday, we're going through this African vulture crisis that many people have termed. We've got these huge declines in many of the species that have been uplisted to endangered and critically endangered, including the African white-backed vulture that I'm going to talk to you about today. And we know that the main driving force behind these declines is poisoning, as was described by many people at the Vulture Symposium yesterday, principally poisoning through indirect or direct poisoning. But remember, what's often lost from this famously and often used figure is these are the percentage of vultures that were found dead. Okay, so these are the percentage causes of those ones that were found dead. It's not the percentage of mortality of vultures. Okay, and that's very often lost, I think, in dissemination of this information. And you could imagine a situation where lead is actually what you could describe as a silent killer. Because when you get a pile of 500 vultures dead, some next to a carcass, you're going to find those, they're going to be reported. If a vulture has high levels of lead, that individual is going to potentially go off under a bush and just die. It's not likely to feature into this database. I think that's worth bearing in mind. So turning now specifically to look at Botswana, so there's been big declines of vultures across Africa. We undertook, this is work again by Becky Garbetz, there's another chapter from her PhD thesis that was published last year as well. We undertook road transects throughout the whole of northern Botswana, and we also detected large and often significant declines in many of the vulture species in Botswana. And then another master's student, Luingo Lepile, went specifically to one of the two main colonies of breeding African white-backed vultures in northern Botswana, and he also detected declines in the number of breeding vultures. So we've got declines in the abundance from the road transects, and then we've also got declines for the local birds in terms of the numbers of breeding birds within Botswana. So we're obviously very concerned about vultures in Botswana for that reason. So could lead ammunition potentially be getting out, like we see in so many other studies around the world? Could that be going into the vultures? And this was the question we wanted to explore. Well, how important is hunting in Botswana? So clearly, this is a fantastic paper, actually, published a long time ago now, 2007, but it charts the importance of the different countries in Eastern and Southern Africa. And you can see that Botswana, although nowhere near the extent of South Africa or Namibia, is important for hunting. It's the 5th most important African country in terms of the numbers of hunters going there. And although we recognize that this obviously was published a while ago, you can see that hunting levels in Africa have increased over time. We don't know what's gone on subsequent to that, but it does appear that hunting is increasing. This is recreational hunting, trophy hunting. So moving on now specifically to look at our study in Botswana. So the hypothesis that we were working on was the idea that lead blood levels in African white-backed vultures, and African white-backed vultures are the most common species, most frequently occurring in Botswana, was the idea that lead levels in this species could be elevated due to lead ammunition from hunting. And if that was the case, we could make a series of predictions. So first of all, if that was true, we'd expect to see lead levels elevated in the blood for African white-backed vultures. And secondly, we'd expect to see that these elevated levels would also be associated with hunting activity. Now, it would have been great if we could have done the isotope work as well, but given where we're working and the constraints of capacity within Botswana, it's just not possible to undertake that kind of analysis. So this is an alternative approach to test whether or not those elevated lead levels could be associated with hunting activity and therefore lead ammunition. And we can make a series of specific hypotheses, predictions based on that hypothesis. The idea there being that lead levels would likely to be higher between hunting seasons, so higher levels inside the hunting season than outside the hunting season, and also that potentially lead levels could be higher for birds in hunting areas than outside of hunting areas, although we accept that other prediction might not actually be met given the ranging behavior, the very wide-ranging behavior that we know that vultures undertake. So in terms of our methods, we used a gas-powered, propelled cannon net that we shot over groups of vultures that were enticed to a baited carcass. We collected data over 4 years from 2012 to 2015. We had 33 trapping events, 14 of which were inside the hunting season and the rest outside the hunting season. We had a total of 15 sites. 5 of those were on hunting areas. These were private hunting estates, and 10 of those outside of the hunting areas. And something very interesting happened during the time of our data collection. In 2014, there was hunting was banned in Botswana. But the very important thing to recognize is it wasn't a complete ban, okay? It was a ban simply on government and communal lands. That's where the ban took place. And our trapping sites, our hunting trapping sites, our hunting areas was actually on private estates where hunting was allowed to continue. Okay, so in total, we caught 566 African white-backed vultures. We took blood from each of those vultures, and then we analyzed these using this mobile lead analyzer? Something like that. Analyzer, that would be it. Okay, so moving on to the results. So I should say that because of the way that the data is collected from that thing that manages lead, we could only group lead levels into 3 different categories. Okay, so we had less than 10 micrograms per deciliter described as background exposure, middle of the road, 10 to 45 micrograms per deciliter as elevated exposure, and over 45 classified as subclinical exposure. And you can see from this result, this distribution of data across these different categories, that a very high proportion of vultures, nearly a third of all vultures sampled, had elevated levels, either in the elevated exposure or subclinical exposure category. And remember, this is blood exposure, okay? So this is indicating relatively recent exposure within the last day to 2 weeks or so, indicating that at least a third of these birds have been exposed to elevated lead levels. Okay, so now we're looking at whether or not there's an indication whether elevated lead levels could be associated with hunting activity. So first of all, we made a temporal comparison, okay? So looking at lead levels inside the hunting season and outside the hunting season. And this shows the average lead levels for inside the hunting season and then outside the hunting season. And you can see that there was a significantly higher levels of lead detected for vultures trapped during the hunting season than outside of the hunting season. And this shows the distribution of those 3 categories for inside and outside the hunting season. So that was the temporal comparison. It looked like there was higher levels of lead levels inside the vultures when they're during the hunting season compared with outside. Next, we compared between hunting areas. So inside hunting areas where we trapped inside those hunting areas and then outside of those hunting areas. And again, although this difference wasn't anywhere near as significant as the temporal analysis, we also found that there was higher levels of lead contamination in those birds trapped in hunting areas. And again, this just shows that distribution. And this is perhaps the most important graph from this finding and a result from this finding. This is the interaction between hunting areas and hunting seasons, okay? And the key thing here is we've got hunting season, again, outside the hunting season, and then when hunting was allowed. And then we've got it broken down. So in grey, dark grey, you can see this is the hunting areas. And in clear and white, you've got the non-hunting areas. And you can see that outside of the hunting season, there's no difference between the levels of lead between hunting areas and non-hunting areas. But when you move into the hunting season, the increase is far greater inside hunting areas than it is outside hunting areas, indicating again that level exposure is linked to the activities associated with hunting. Last result here is in relation to lead levels before and after the national hunting ban, okay? But remember where that ban took place, only on government and communal lands. But we found apparently a contradictory result where levels of lead were elevated after the ban compared with before the ban, which we wouldn't have expected. But as I say, it isn't actually as contradictory as you think because of where that hunting ban took place and where we sampled from, and I'll go on to explain that now. Okay, so to conclude, we found that over 30%, so a third of African white-backed vultures had elevated lead levels, meeting our predictions if lead ammunition could have been involved in the cause of this. The key thing here was that the patterns of lead exposure were consistent with the hypothesis that lead ammunition used in trophy hunting is contributing to these levels. And this is from trophy hunting, but obviously other lead ammunition can also be important. For example, we know very well that there's a large amount of poaching within Botswana, and that could also be important, a cause of the elevated lead levels. The increase in lead after hunting ban is not as contradictory as you first might imagine, and that is because a lot of people think that, well, if hunting levels had continued at similar rates, but you've suddenly got these areas of hunting that are land that aren't able to be used, then hunting is likely to be concentrated within these private hunting reserves, which is where we did our sample. And the other thing that people speculate about and have suggested is that in these areas where hunting was banned, poaching, there was no longer that resource and that incentive for local people to not go out poaching. And there's a speculation that poaching also increased in those areas, which might also have contributed. So could lead levels be affecting vultures in Botswana? Well, historical research suggests that they could well both be having lethal and sublethal effects on vultures. But I think the most important thing for me is that even if lead poisoning is not the driving force behind vulture declines, and I'm not speculating, I'm not suggesting that it is the driving force behind the declines of vultures in Botswana. To me, it links back to something that John very eloquently said this morning. It is arguably a more tractable solution, okay? So yeah, we have to tackle those big mass poisoning, those human wildlife poisonings, okay? But they're going to be really, really difficult to do. But one thing that is more tractable and that would help vultures, there's no doubt about it, is that if we kind of phased out lead ammunition and we recommend the use of non-lead ammunition. And so I would argue that that resolution from CMS and that phasing out of lead ammunition really would help vultures across their range if we managed to do that. Okay, and I'd just like to thank the people that have supported this research, and thanks very much for listening.